Okay, hello and welcome to this section of HUP 112, Logic and Philosophy. My name is Richard Brown, and we are now moving on to Chapter 3, discussing categorical propositions. And today we'll be talking about the square of opposition. So you recall from last time our four kinds of propositions. So we have our A proposition, our E proposition, our I proposition, and our O proposition. I'll write them in this way so that we can talk about them um, in a little bit more detail. So remember that the A proposition stands for all S are P. The E proposition is no S are P. The I proposition is some S are P. The O proposition is rendered in modern ways as some S are not P. And there is some controversy about that we may have some time to talk about, but there has been an argument's been made that originally when Aristotle wrote this, he used the expression not every S is P rather than some S is not P, and that does tend to make some differences, and if you're interested, we can talk about that. Now, each one of these sentences, according to the logic that we're talking about here, is associated with a truth value, and it's one of two truth values. It can either be true or it can either be false. And the square of opposition is a way of summing up the relationships that exist between these sentences. So take the sentence all S or P. Suppose that we're talking about dogs and mammals, so that we say all dogs are mammals. Okay, so that we say all dogs are mammals. Suppose that we know that this sentence is true. One question that immediately arises is what the relationship between the truth of that sentence is to these other four allowable sentences, logically speaking. And what Aristotle pointed out, and what is definitely still true today, is the relationship of contradiction. A contradiction, as we use the term in this class, is a pair of statements or propositions where it must be the case that if one is true, then the other one is false, or if one is false, that the other one is true. So that if we know that all S are P is true, so if all dogs are mammals, then it must be the case that some S are not P is false. All dogs are mammals. So if we know that's true, then that logically entails that some S are not P must be false, because those two statements are contradictions. They can't be both true at the same time, and they can't both be false at the same time. One must be true and the other must be false. Now, of course, if we have a false sentence here, so if this says all dogs are reptiles, if this says all dogs are reptiles, then that's false. Well, then that logically entails that some dogs are not reptiles is true. And remember that some in our language means at least one. So when we say that some dogs are reptiles, what we mean is that there's at least one thing that's a dog and also a reptile. And so a contradiction here goes from side to side, and contradictions are defined as where you know the truth value of one, it entails the opposite truth value for the other one. And so the A and O sentences are contradictory, whereas the E and I sentences are also contradictory. So that if you know that no dogs are reptiles, no dogs are reptiles, if you know that that's true, then it must be false that some dogs are reptiles. False. It must be false. So the relationship of contradiction goes diagonally. Now, in the so-called modern square of opposition, this is as much logical structure as you get, and the relationship between these other sentences is undefined. So if you ask about these relationships here that go around the outside of the square, in the modern way of thinking, these are undefined. In other words, it is the case, according to the modern way of interpreting these, that if you know that this is true, logically, for instance, if you know that the A sentence is true, that tells you nothing, logically speaking, about the truth value of the I sentence. The I sentence could be true, or the I sentence could be false. And the main reason for thinking that, according to the modern view, comes from thinking about these kinds of statements involving non-existent objects. So let me just take this down here for a second. So take our sentence, all dogs are mammals. So there's one sentence. We'll call that sentence number 1. But now here's another sentence, sentence number 2. And we'll say that all unicorns are mammals. So here are two sentences. They're both categorical statements. They're both well structured categorical statements and allowable by our syntax so that they count as well-formed sentences in our logic. And we are told that every statement, it has a truth value that's either true or false. And so all dogs are mammals. Well, it's quite easy to see that that's true. But what do we say about all unicorns are mammals? There aren't any unicorns, and yet it seems natural to say that if unicorns are at least thought of as a horse that has a horn, then they probably would be a kind of mammal. Of course, we don't know that. There aren't any unicorns, but I guess on a standard assumption, we want to say, yeah, it's supposed to be true that unicorns are mammals. So that's very interesting. Now, when we think about these two things, we could wonder about, well, what makes it true that unicorns are mammals versus what makes it true that unicorns are dogs? And those are interesting questions. But the question for us here is, what is the relationship between these sentences and the corresponding I sentence? So the I sentence here, we'll call this 1I. The I sentence here would be some dogs are mammals. And down here for 2I, we would have some unicorns are mammals. Okay. Let me just rewrite that. M-A-M-M-A-L-S, mammals. Okay. So some dogs are mammals. Remember, we interpret this according to the way that we interpret these sentences. The meaning of this sentence is that at least one thing exists which is both a dog and a mammal. So we read the sentence, some dogs are mammals, as telling us, as logically meaning, as having the meaning that there is at least one thing, there exists at least one thing, which is both a dog and a mammal. And so that's what the I sentence means according to our semantics here. And this is what we call existential import. It has existential import because the sentence, when it's true, implies that there's something which exists in the world. So that if you know that some dogs are mammals is true, then you can infer from that there's at least one thing which is a dog and also a mammal. But now, and so that seems true. It seems true in this case that some dogs are mammals. And it seems true that all dogs are mammals. Okay, so that's okay. Now what about unicorns? Well, I said already we could debate about whether that sentence is true, but it seems as though we can give some idea, some sense to the idea that that's a true sentence. But what about the sentence, some unicorns are mammals? Well, according to our semantics, according to the meaning that we attach to these sentences, what that sentence means is that there's at least one thing that exists which is both a unicorn and a mammal. And that seems intuitively to be false. And that seems intuitively to be false. But there's a good case to be made that all unicorns are mammals is true. All unicorns have horns, another true statement, but that doesn't logically seem to imply that there exists an object which is a unicorn and a mammal, or at least that would be very strange if we took that to logically imply that there existed a unicorn in the world, and that you could prove that by logic. Now, how does this relate to our square of opposition? Well, it relates as follows. So you remember our square that we have here, the A, the E, the I, and the O sentences, and we already defined the relationship of contradiction. And Aristotle recognized other, and this is the only logical relationship that the modern square, the so-called Boolean interpretation, this is the only logical relationship that it recognizes. But in the Aristotelian tradition, they recognize other relationships. So, for example, this relationship here between the A and the E was the relationship of being contrary. Being contrary is not the same thing as being a contradiction. So you remember, when you have a contradiction and you have your A and your O sentence together, if one is true, that means the other one is false, and vice versa. There's no way to avoid that according to the way the rules are set up. If one is true, then the other one is false. But being contrary with each other is not as logically as strong of relationship. So the way that Aristotle defined it is that they could both be false, but they can't both be true. So for instance, take the A sentence. If the A sentence is all dogs are mammals, so that we have all dogs are mammals here, let's just put that. And we know that that's true, and therefore we know that the O sentence has to be false, that some dogs are not mammals. We know that given what we've just said. But now what about the corresponding E sentence, which is that no dogs are mammals? No dogs are mammals. Now, what about that? Well, that sentence is false, so that's okay, and that's okay. Now, what about when we say, so they can't both be true together, so this one is true, and that makes this one false, and we're okay with that. If all dogs are mammals, and then that can't mean that there are no dogs that are mammals. But now suppose that we change dog with unicorn. So the contrary relationship is not as logically strong as the contradiction relationship, and the way that Aristotle defined it is that at least one of them must be false. At least one of them must be false. So if you take our sentence here that all dogs are mammals, all dogs are mammals, and then the corresponding sentence, no dogs are mammals. If you know that all dogs are mammals is true, then the corresponding E sentence has to come out false. At least one of them is false. And if you know that no dogs are reptiles is true, so if no D are reptiles, if you know that's true, then all dogs are reptiles comes out false. So at least one of them must be false. But it's easy to see that you could have both of them be false. So an easy example here is if you say all animals are dogs. All animals are dogs. That's false. But the corresponding E sentence, no animals are dogs, that's also false because there are some dogs and those dogs are animals. So they can both be false here, but there must be at least one of them which is false. So they both can't be true together. So that's the contrary relationship And a kind of analogous relationship holds down here between the I and the O sentences. And those Aristotle called subcontraries, or they have come to be called subcontrary. And whereas the contrary relationship, at least one of them must be false, so they can't both be true. The subcontrary relationship is that at least one is true, and they both can't be false. So take our sentence here before. If some dogs are animals, that's true, because there's at least one dog which is an animal. So some dogs are animals, and this sentence over here is some dogs are not animals, and we take that to mean that there is at least one thing which is a dog and which isn't an animal, and so that comes out to be false. And this one is true, and that one is false, so that's fine because at least one of them has to be true according to the contrary relationship. At least one of them has to be true, but remember, they could both be true. For instance, some dogs are brown. That's true. Some dogs are not brown. That's also true. So the subcontrary relationship is, again, a different kind of opposition, what the book calls partial opposition, whereas contradiction is a much stronger notion of opposition, whereas one having the truth value logically entails the other has the opposite truth value. Now, the relationship that Aristotle defined here is called subalternation. And the way that we talk about that is that truth flows downwards and falsity flows upwards. So that's subalternation. And what that means is that if you know that an A or an E sentence is true, then that entails that the O sentence down here is true, or the I sentence is true. Whereas if you start from down there and know one of them is false, then you can go back up and infer the falsity of the other one. So for instance, to give an example, if you know that all dogs are mammals is true, then some dogs are mammals is true. And it's that relationship right there which has been the source of a lot of trouble, because if it is the case that the A sentence is true, if that means then that the corresponding O sentence is true, it seems to suggest that the A sentence has some existential import, and then we get into trouble with the unicorn. So if all unicorns have horns, if that means, and you accept that as true in whatever way, then that you don't want that to logically entail that there exists a unicorn, that some unicorns have horns. Now, the way that Aristotle handled this, or the way that the book says that he handled it, is that they accepted these kinds of inferences as valid when they were done with existing things, and denied that they were valid when they were done with things that didn't exist, so that they would accept the inference from all dogs are mammals to the claim that some dogs are mammals as valid, but they would deny the inference from all unicorns have horns to some unicorns have horns. Now, if you accept this, the traditional square of opposition, then you have the ability to compute truth values. If you know the truth value of any one of these things, you can compute the truth values of all of the other ones. So suppose that you know that all dogs are mammals is true. So we'll say that that's true. Well, then we know by the contradiction relation that the corresponding O sentence is false. Okay, so if this one is true, then this one is false. And of course, subalternation tells us that if the A sentence is true, then the corresponding I sentence is true. So now we know that that sentence is true. And of course, by the contradiction relationship, we know that if the I sentence is true, then the corresponding E sentence over here has to be false. And now we see that the A in the E sentence, one is true and the other is false, so at least one has to be false, is preserved. And we see the I and the O, one is true and the other is false, so we see at least one is true is preserved. And all of the rules, if this one is false, then that one is false, this one is true, and that one is true, so that you could compute the truth values of these kinds of what are called immediate inferences simply by looking at the square of opposition. Something which can't be done in the modern square of opposition. So in the modern square of opposition, which denies that the A sentence has existential import, and so therefore, if you know that the A sentence is true, you don't know if the corresponding I sentence is true. You have no idea whether it's true or not because the A sentence just tells you something which could be true even if none of those things existed. So even if every human being died tomorrow, it would still be the case that all human beings are mammals, because that's a general truth about human beings, and it doesn't really seem to be the kind of thing that has a dependence on any human beings existing. If we all died of smallpox tomorrow or some horrible disease, then it would still be the case that all humans are mammals. It's just that there wouldn't be any mammals down here. So that relationship is gone. And of course, now this relationship, the contrary relationship, you say, well, isn't that preserved in the modern interpretation? And the answer is no, that's not preserved.